Number 37. In the Lewis structures listed here, M and X represent various elements in the third period of the periodic table. Write the formula of each compound using the chemical symbols of each element. And then they give us A through D. Okay, so first things first, they tell us that we're only allowed to use elements from the third period. So we have to figure out where the elements of the third period are. So remember, periods go left to right. So here is the first period, and all of these elements, so there's two elements, hydrogen and helium are the first period. This is all the elements of the second period. So we're only looking at this period here, from sodium all the way to argon. So we're only allowed to use these elements. So that's first thing. Now we just have to figure out what each one of these means. All right, well, for A, they're telling me that I have a M, so an atom, that was a 2+ charge, and it is forming a compound with another atom, right? And it's an ion because it's also charged with a 2-. And I see that the X has all the electrons and the M has no electrons. That means that this has to be the metal and this has to be the nonmetal. Also, in ionic compounds, the metal always has the positive charge and the nonmetal always has the negative charge. So that's also how I know as well. Now, we can find out what these atoms are by looking at the charges. We should know the oxidation state trend. So group 1, all these atoms will always lose 1 electron, +1. This group will always be a +2. It will lose 2 electrons, +3, +4, -3, -2, -1, and 0. So basically, we just have to match these charges to their atoms. So the metal was a +2 charge, and I'm in group 3. So here's the +2. That's magnesium. So this would be Mg would lose the 2 electrons, and it would bind with something that had a -2 charge. Well, we're only allowed to use group 3, and the -2 is silicon, which is in group 3. So there's the compound, MgS. There's no multiples. There's one of this and one of this. So it's just MgS. So that's the answer to A. B. For B, they tell me I have a M, which is a 3+, and I'll put the 3+ inside. It's a plus, so that means that it's a metal. And then the other one has all the electrons. And that one was a -1 charge. However, there's 3 of them. But the charges are more important. The +3 signifies that I'm over here, and I have to be in period 3, so that's aluminum. So I know that this metal was Al, aluminum. And now we just got to find out what the nonmetal was. And the nonmetal is a -1. So -1 is over here, oxidation state. It was chlorine. And in order to make this compound work, to transfer electrons, I needed 3 chlorines for every 1 aluminum. So this would be AlCl3, and that is the compound. Now, notice how I'm not adding the charges here, right? I'm not saying Al +3, Cl -1, because the ionic compound as a whole is neutral. These are just showing you what's happening inside the compound. But the actual compound, when you state it like this, it is neutral. So that's that. C. We have a M with the plus. Now, they don't tell me specifically what number, but we assume it's a 1. There's 2 of these for every X, which has all the electrons. It's the octet. And that's a -2. All right, well, still period 3. The positive means that this is a metal, right? The negative means that this is a nonmetal. So let's find these charges. +1 is in group 1, and period 3 would tell me that it's sodium. So I started off with sodium, and in order for this compound to work, I needed 2 sodiums per every 1 of the nonmetal. So I need Na2, and now the -2 is over here, We have period 3, so that's sulfur. And I only needed one of those, so it would just be Na2S. And that's the end of that compound. And then let me do D over here. We have a metal that's a +3, and I need 2 of them to make this work. And here is another ion that has all the electrons, and it's a -2, and I need 3 of them. So this is a positive, this is a negative, so I know that this has to be the metal, and this has to be the non-metal. And now we look at those oxidation states. The metal had a +3 in period 3, +3 is over here, so it has to be aluminum. So Al, and I have 2 of them, so I have to put Al2. And now the nonmetal has a -2 charge, and -2 is over here, group period 3, so that's sulfur. So this would be sulfur, and in order for this to work, I needed 3 sulfurs. So that's it, and there's your compound. And it makes sense. If we look inside, each aluminum was +3, each sulfur was -2, and if I multiply the charge with how many aluminums I have and add it together with the sulfur charges and how many of sulfurs I have, it will be neutral. +3 times 2 would give me an overall +6 for aluminum. -2 times 3 will give me an overall -6 for sulfur. And if we add those together, you get a neutral compound. So that's why whenever you write ionic compounds, you never write the charges. Okay, and this is done. 37 is done. It's getting easier. I hope it is. Let me know in the comments what you guys think. I would love to hear from you guys. That would be awesome. Thank you so much for coming here. Hopefully this helped. Subscribe to the channel. Thank you for that. I'll see you guys in the next question.